The TDAP creates a metal-to-metal seal in the annulus between two casings to prevent the migration of hydrocarbon fluids and gases leaking to the surface. It achieves this without the use of mechanical parts or elastomers to assist in anchoring and sealing, and has been developed to allow the placement of cement above and below the tool while still creating a gas-tight barrier that eliminates the need for future expensive interventions and unreliable cement squeezes. Each TDAP segment is machined out of a bismuth-based alloy that expands on solidification. There are a number of conduits that run along the length of the tool. These conduits allow circulation through the tool while running in hole and during cementing. Each unit is fitted with both internal and external springs. Before activation, the alloy provides resistance to the springs. Once the alloy begins to melt, the springs exert both compressive and expansive forces, severing the cement that is solidified in the conduits. The alloy is selected to suit the downhole conditions after taking into account downhole pressure, well bore temperature, differential pressure requirements, and resistance to H2S, CO2 and corrosion. The segments are placed on the outside of the inner casing string. Packing elements are fitted at each end. Stop collars hold the tool in place. Centralizers are fitted above and below the stop collars. A bow spring centralizer sits below the assembly. During the drilling and completion phase of the well, the TDAP is attached to the inner casing string and run in hole as part of the completion. Cement is pumped down the inner casing. The packing elements at either end of the tool do not form part of the sealing process. They're used to ensure that the cement is directed through the conduits and not along the outside of the tool, which will create a microannulus of cement between the TDAP and the outer casing. Once the cement has been pumped, the packing elements play no further part in the sealing process. Once the string has been run and cemented in place, the modified thermite heater is run inside the inner casing on wire line. Once in position using a casing collar locator, the heater is activated and the alloy on the outside of the casing is melted, turning to a liquid metal with a viscosity similar to water. During the melting process, the springs that are held in place on the outside and inside of the segments are released, and with a chopping action, they break the cement conduits that are running through the tool. The alloy solidifies and expands within minutes, creating a metal-to-metal gas-tight seal between the inner and outer casings, with no communication path through the cement conduits. The heater is then retrieved from the well, leaving a gas-tight metal-to-metal seal.